Okay, so today is kind of like a one-off. It is an entire module on debugging, but it's a shorter module than usual because, of course, the arrays modules was a little bit longer, and it's shorter because we're getting to the point where we're going to be doing the midterm. So it's not next week. The next week is going to be your debugging module, but of course you've got those first 3 days off for spring break. And after that, when we come back for our first full week, we'll cover a little bit of strings. Then we'll do a midterm review, and then your midterm is on that Friday. The midterm review is going to take the form of I'm going to bring an old midterm, in fact, last year's midterm, and we're going to do it. And you'll see what a midterm looks like for this course. Yeah?
So how does, with attendance points, I know there's a couple of us that have to miss the lab on Friday for a special, it's a special event that is part of this scholarship program. We're part of
Okay.
Making us miss on Friday. We have to go.
This Friday, or?
Yeah, this Friday during the lab. So I was just wondering how like attendance points work.
Oh, remember that. Without any accommodations whatsoever, if you get at least 30 out of 40 on the other 40 points, you get your attendance points. Period. Right?
Okay, so as long as I plan on like completing the lab and hack and stuff a day in advance just to have
Then-
it done since I can't be there. But
Then you could have 40 out of 40, and you get your other 10.
okay,
Right.
awesome.
And if there is anybody that is needing accommodations for other excused things like that, let me know.
I talked to some of the TAs too, or one of the TAs, and
Okay.
they said to just let you know. So.
Sure, great. All right. Tooling is not just about debugging here. Remember, we are online, so if you have any questions, go ahead and post to Piazza or to the YouTube live stream here I am watching. I will show you the bulk of GDB here. But I want to take this opportunity to draw your attention to some of the tools that you've been exposed to, that you've used, and that you probably should take it upon yourself to use more often. For example, source control. Source control and software versioning. Right? So what tool have we been using for source control? You've been checking everything out every week in your lab. Sometimes for your hacks, you clone stuff out. I deliver all the notes through it, etc. What? Git, exactly. Now you might say GitHub. GitHub is a commercial entity now owned by Microsoft that uses Git and provides a web-based graphical user interface for Git. But Git is not just GitHub. You also GitLab, Bitbucket. Those are also other commercial or free and open source software solutions that provide web-based Git solutions. Git is a distributed VCS, version control system. Right? Way back in the dark ages, we had CVS, which is not VCS. It's a content versioning system, I think it was. That was like the first version of software control, where you could check things into a repository. It would keep track of changes, and people could check that out, make changes, check those into the repository. Then came along Svn Subversioning, and then along came Git that provided a distributed version of this. So when you clone something, you have an entire history of the entire project. So if it's a very large project or a very old project with a lot of changes, when you clone something, the initial clone is going to be a very, very large file. But in any case, it's a way of keeping track of software changes, right? We walked you through that in Lab 1 or maybe Hack 1, where you make changes, you commit those changes locally to your version, and then you can push those changes out to a shared version. Other people can pull those changes. So that way you can distribute the work among many different people. You can still have a centralized location with the master control software, but you can also have people contributing to it. You can play gatekeeper, and through, say, GitHub, you can have what are called pull requests. So if somebody says, I've got this feature that I think that should be added to this project, they can go ahead and develop that feature, debug that feature, test that feature, and then make a pull request. Will you please add my changes to your project? And you can say, yeah, that's great. I'll go ahead and pull those, I'll go ahead and merge those changes in. I'll pull those changes. If not, no, that's not the direction we want to go. Or, you know what, I actually tested that and there's a whole bunch of bugs with it. No, reject, right? It is a way of keeping track of those things administratively as well. So you've had some exposure to it. Tell me, how many people are using Git as a matter of course for, say, all of their hacks? All right, 1, 2, maybe? All right, why? Justify it to the rest of us so that we all start doing it. Why?
I can use Git and have it on my laptop and also on a desktop.
So you can have one central copy, and use it on multiple machines, right? Why would that be good? What if somebody took a hammer to your laptop right now?
Oops.
Yeah. And you weren't using Git. Bye-bye all source code, right? In other words, it is a cloud-based backup, right? You'll not believe how many times I have a student coming to me and say, I programmed 1,000 lines of code, 10,000 lines of code last night, and it all worked. I swear it all 100% worked. And then my computer went down, and now it's all gone. And my question is, oh, did you use Git? Because you'd still have it right now, right? If you did. And it usually takes being burned like that once to finally learn your lesson, right? Start using Git, even if it's just simple stuff like your assignments, right? You check it in after your day. You don't have to check in every single change you make. Check it in periodically. If you're using CS50, download something and periodically so that you have a backup copy of everything. Git is the ultimate backup server, right? Keep everything private, of course, because you don't want to share your code with everybody. But it's a great way to do cloud-based stuff. Yeah, go ahead.
I also think if you're using VS Code Online, I think that has like a graphical user interface for Git.
So I'll add convenience in there, right? Right. Why else? The vast majority of you are working in pairs at least, right? And one of you turns it in, right? If partner A has a copy, how do they get that copy to partner B, which is the one that has to turn it in? How have you been doing that? Anybody want to offer how have you been doing it? Anybody? Anybody want to admit? Oh, I attached it to an email and sent it to him. I put it on a thumbnail drive and I gave it to him. This is 2022. Come on. Yesterday I was in a class on the other campus, and one of the other students was lamenting that they were taking this ethics course and that they had to buy a blue book. And my jaw just, you all know what blue books are, right? You don't know what a blue book is. Good, right? But this tells you how ancient this instructor was. Blue books they're blue, or sometimes they're green, filled with lined paper that you had to buy because that's what you did your essay exams on, right? You wrote your essays in these blue books. You've never seen blue books before? Take a history course, maybe you have to still do a blue book. My jaw dropped because I said, it is 2022, right? We are nearly a quarter century into the 21st century. Why are you still using paper, period, much less a blue book? Join the rest of us, right? Join the rest of us and start using Git, right? Don't transfer via, I don't know, what is it, Dropbox? Or
Copy paste it into a shared Google Doc.
Google Doc. Don't do that. What's the other Dropbox? OneDrive. There we go. Drive, etc. Right? You are engineers, not secretaries. Okay? Not to denigrate secretaries; those are perfectly valid tools for non-technical people. But have some self-respect. Start using some Git. Right? So don't transfer things via cut and paste. Don't transfer them via email. This is 2022. Okay. Git, by the way, is over 15 years old. Right? Does anybody know who made it? Linus Torvalds. Right? Why did he make it? In order to keep track of the source code for Linux. Right? Another tool that you've been exposed to is build systems. Right? For example, make, or the more modern CMake. Right? CMake is, I think it's the C is just for C, but make is a more general build system. And I've got the example here that you may or may not have taken a look at the nitty-gritty stuff. We just gave you the make file and told you how to build. Right? All you have to do is type make, or make this, or make that. It's another programming language. Right? It's a build programming language. You can have variables. You can have what are called, you can have rules and dependencies. So for example, to build image driver, it depends on these files. Okay, then that tells make to go out and, okay, how do I make imageutils.o? Here's the rule to make that. It depends on these things. So I have to do that first. There is a dependency graph here. In order to create this thing, I first have to create this thing. In order to create this thing, I first have to create this thing. Right? That kind of complex relationship is all handled by a make file, and it is all taken care of by make itself. Right? How does it actually get built? Well, here's the actual build. Instead of typing these commands over and over and over again, GCC that, GCC that, GCC that, all you do is put all those rules into a make file and have one single command to rule them all. You can also have other rules here, like, for example, cleaning up. All of your intermediate build files, like .o files, object files, and temporary files. Sometimes if you're using a text editor, it'll make an automatic backup with a tilde attached to the end. So if your text editor crashes, you still have a copy of it. We'll go ahead and clean those up as well. Right? You can make clean, and it'll clean up all that stuff. This is only scratching the surface. This is a bare minimum simple make file. Right? You can get super, super complicated. What if you have to have a different rule to build for a Windows system and another rule to build for Linux, right? Because their libraries are completely different, right? One file takes care of all of that. Yeah?
Why do you have the GNU 99 bit in there? What is that for?
That's a good question. That's the STD is standard. So what standard do you want? Do you want to go back to 1979 and use the ANSI standard? Or do you want to come at least 23 years in the past and use the C99 standard, right?
Is there not a newer one?
There's a C11, I believe, C11 standard. It didn't add much of anything. Thank goodness it doesn't add anything, because we like our C to be old school, because we don't like change, right? Each standard only comes out about every 10 years. If you had changes every 18 months, everything would be breaking, right? For example, the newer versions of Java, they've committed to making a new version every 18 months, right? That doesn't stop people from still using Java 6, for example, because they want consistency, they want stability, right? And so the C99, C11, formerly C1X, I only did that because I don't think that there's anything that you need in a modern standard. The GNU is actually an extension of the C standard. There's an ANSI C standard, and then GNU decides, we want to add these bells and whistles. So we'll go ahead and use that standard because we like those bells and whistles. Right. Question over there?
I used it already.
Okay, all right. And then God help you if you've got a terrible language like, say, PHP or some JavaScript frameworks that not only make updates, but they make backwards incompatible updates all the time. So that, congratulations, you have to rewrite everything, right? Python unfortunately did that, but fortunately, hopefully they will only ever do it once between 2 and 3, right? Oh, well, hopefully. Hopefully they never do that again, right? Do not make backwards incompatible updates, right? You also have, beyond that, dependency management, dependency managers of external libraries. You haven't had to do this in this class because we made sure everything that you needed was installed. For example, CMaka. If you use the CS50 IDE, it was installed there because we went to the admins and said, please install this. If you were using something like this, there is no CMaka installed, and so what you would have to do is you would have to install those things using something called apt-get. Right? apt-get it allows you to install entire packages or development packages, something like that. And if you install package A and package A actually uses another library, it'll resolve all those dependencies and install everything for you. Right? You don't have to do that because we made sure that it was all installed before the semester started. But apparently in fact, you know what? Let's go back to CMOC over here. In fact, yeah, there's a workaround there. It's still there. Prior to this semester, they took away the sudo access. So what they made it so that you couldn't install stuff on the CS50 IDE. And we went into, I went into panic mode. It's just me. I went into panic mode because that means that I would be having you download and install the entire project and then compile it from scratch. So it was going to be about a 15-step process. And not everybody is good at following instructions exactly. So I was panicking, and so I went back to the admins and I said, will you please install this? Oh yeah, sure, we'll get to it. And of course, not trusting them, I said, all right, well, I need a backup plan, right, in case they don't do this. And so I went and I tried to take that 15-step process and I tried to reduce it down to 3 or 4 steps. How? I grabbed all those files, I compiled them, I put in a compiled static library here, and then I documented everything I did because, where is it? It should be in development or workaround, there we go. I developed, there we go. The good folks at the admin department of the CS50 ID revoked sudo access, et cetera, et cetera. So I documented my own work. Why? Because if I come back 6 months from now and I need to remember how I did it, right? I don't want to have to reinvent and redo everything that I did. So I put in a step-by-step process here for myself to how to go about doing this, right? And ultimately, we didn't have to because they did ultimately install it and at the last minute. And so I took all of this away. But that's how you manage dependencies. You sometimes have to go out and get the raw libraries and install, and not, instead of installing them, you have to compile them from scratch, right? But dependency managers will help you with all that. apt-get, in coding, like if you're in Java or something, there's a tool called Maven. It goes out and to Maven Central, which is just a central repository of all these libraries, and grabs these libraries and all their dependencies automatically for you. All you have to do is say, I need a MySQL library. Okay, we'll take care of that for you, right? And those are the kinds of tools that you should be taking a look at, right? Package managers, et cetera. This all goes into something called Devops, right? Which is short for Development Operations, right? So in a big enough organization where you've got dozens or hundreds of software developers, you don't want everybody to have to do everything for themselves. So you can take some of these items and you, like building scripts, dependency managements, installations, stuff like that, and you can consolidate it to a few people that are responsible for doing that for all of the developers. So you don't have to install everything, so that you don't have to resolve all these dependencies. And those folks are usually called DevOps. They never write any actual code. They write the code that manages the code, right? And if you've got anywhere near a complex organization, you need several of these people. The last industry job I was at, we had, I think, 100 developers, and there were at least 2 or 3 dedicated. They were 2, and then they had wanted a third DevOps. We didn't call them DevOps back then. That's a neologism right there. But they were just responsible for making build scripts and deployment scripts, and that's it. Right? They manage those as part of their full-time job. Right? So that is out there. Right? All right. What else have we been looking at? Unit testing. Right? How do you know if your program is correct to begin with? It compiles. Is that enough? No. You have to have some testing, right? Ad hoc testing, where you just run it really quick to see if I input 10 and I expect 2 out of it, do I get it? 2. Yes. Okay, great. That's a sanity test. That's an ad hoc test. As needed test, right? But that's not formal at all. We then looked at informal unit testing, right? Where you write your own framework. And by that, I simply just mean you have an you run the test, you compare it to the expected output. If it's right, you pass. If it's not, you fail, and you increment a counter for the number correct and the number wrong, right? Why do you have to rewrite that boilerplate all the time? Instead, you can use a formal testing framework. And what's the unit testing framework that we used in here? CMACA, right? That's just one of many. That was originally a Google project, and Google is famous for abandoning everything good. So thankfully, somebody else took up the reins. I forget what it was originally called, C Mockery or something like that, or yeah, I think it was Mockery. And somebody took it up and changed it into an open source project, and it's an excellent C unit testing framework. By no means is it the only one. There are plenty of others out there, but when I decided what to use for this course several years ago, I evaluated 2, 3 of them. This one was by far the easiest, right, to use. What does MACA stand for? What is mocking? Mocking is making fun of somebody. All right, but what else is it?
Mock objects, right?
Mock objects, exactly. What is it? It's a mock-up, right? If you want to build something, and you might be able to build it out of cardboard or something first as a mock-up. Ever done that before? Right? You build it out of cardboard so that you can get a sense of scale, so that you can carry it around and see, will it fit here, will it fit over there? Or you go high-tech and you do it in a CAD program or something. Or you move it around, or what's that? I think it's also Google. Is it SketchUp? Or what is it? Yeah, you do it in SketchUp, and you put it into a scaled room, and you see what it looks like, right? You do a mock-up of it. And that's what this is. You're mocking up test data, tests, to try to break your software, right? And you try to be as adversarial as you can, right? You try to break your software so that you can find the bugs, right? You don't know if there are bugs unless you have tests, right? Unless it fails eventually. And if it does fail, oh, well, that gives you a new test, right? It was working before, now it fails. What did it fail on? It failed on the input of 10. Oh, we never tested that before. Let's take that and add it to our testing framework. Now we have a test that we know fails, and we can go back and do a bug tracking, right? And we'll get to that here in a second. Static analysis tools, right? So again, static analysis is done before you compile, right? It is an analysis on your code, right? Some examples. The simplest example that I've always given you is GCC, the wall flag, right? Turn on all warnings. Another would be GCC W extra, and you can do both of these, right? W extra is, I don't know why, but turning on all of them doesn't actually turn on all of them. It doesn't turn on the extra ones. So you can go with the warnings, all of the extra warnings as well. Sometimes, again, it's kind of rare, but sometimes that will capture more values, okay? And you can also use other compilers in this manner, right? I think that's it, isn't it? Let's go ahead and try it over here. I've got an example here, array demo. So do I have Clang? Clang. There we go. Yep, I do. So Clang array demo. Oops, I'm not in the proper CS1 lecture. Clang array demo. .c. It's just like GCC. Okay, and it is giving me a warning here. But now what I want to do is I want to analyze. Analyze. All right, that's it. That's the only warning that it's going to give me. Oh well, I thought it would give me some more warnings there, but nope. If I tell it to analyze it, it'll analyze it as it's compiling. Okay, but that could pick up another class of warnings. It used to be that Clang was a lot better than GCC, but more recent versions of GCC have upped their game, and they are reporting more and more static analysis warnings and stuff. So they're on the same level, right? What we're going to focus on today, though, are dynamic analysis tools. Let me give myself some room here. There we go. So dynamic analyzers analyze code when it is being run. So for example, valgrind. I'm going to go ahead and show you the full way of doing this. First, compile with a G flag. All right? That G flag is going to tell the compiler to retain all references to line numbers, to function names, to variable names. Because ultimately, when you compile something to machine code, it's just a bunch of ones and zeros. If you want to know what line something happened on, that information is gone because the assembly code and thus the machine code, the lines are completely different from your original source code. So we're going to compile this with a G flag, this bounds here. First of all, it's a very simple program. Tell me what's wrong with that program, by the way. Can you see it? Does anybody see it with the naked eye? What is it doing? It's iterating over this array of 100 elements, and it's just setting them all to like 1, 2, 3, 4, 5, 6, all the way up to 100.
Oh, it's iterating up to from 0 to 100.
Yeah, it's not an idiomatic for loop, is it? Right? So if you're used to seeing idiomatic for loops all over the place, you can catch that pretty easy with the naked eye. If you don't, that's all right. You can go ahead and use valgrind. I'm going to use valgrind to check for a lot of stuff. I'm going to go ahead and check for all memory leaks, all kinds of memory leaks, and then all of the other things that it's going to report to me. What's one thing that it's going to report to me? When it gets to the end of this loop, is it going to access a variable that belongs to me? Nope. So, well, let's just run it. See if it errors out here. Nope. Right, it didn't print anything, but that's okay. Why didn't it error out? There were 100 elements, but we accessed the 101st element. That memory belongs to me. You can screw up your own memory as much as you want, right? But it's still undefined behavior. Valgrind, however, will detect that. So again, these are the flags, and this will be in the notes. You don't have to hurriedly copy this down or anything like that. But I'll run that program again through valgrind. What's going to happen is that program's not just going to run. Valgrind is going to run and then simulate the run of that program and then look at it and analyze it as it goes along. It's a pretty small program, so it was really quick. If it was a large program, of course, the simulation of a program is necessarily going to be slower than the running of the program itself. So you do have to be patient here. 400 bytes in one blocks were lost. Right? Actually, let's go all the way back up to the top here. What do we see on these lines right here? There's a report of an error at runtime. An invalid write of size 4. Where? In main, in the file bounds.c on line 10. What were we doing on line 10? We were accessing the variables. All right? 0-byte block after a size of 400 allocated. Right? Malloc allocated this block of memory array at 400 bytes, right? 4 times 100 bytes. And we tried to access something that was of size 4 beyond that. I mean, it's not telling you all the details of, by the way, there were only 100 elements in here and you accessed the 101st, you might want to check that out. By the way, and instead of, it's not going to be as sophisticated as saying, you need to change that less than equal sign to a strictly less than sign, right? It's not going to do all your work for you. If we had that level of automated programming, we wouldn't have this class, right? We would have programs that 100% wrote other programs. And when that happens, humanity's over. Right? Literally, humanity is over. We will become the Eloi, if you know that reference, right? Eloi of Time Machine, Jules Verne, right? No? He goes millions of years in the future, and humans have evolved into 2 different races, the Eloi and the Morlocks. And the Eloi are very peaceful, smart people, right? But he finds out later that they're just cattle because the Morlocks eat the Eloi. Right? All right, read some science fiction. There have been many, many movies. There's one in the 60s, there was one in the 2000s. All of the movies are terrible, though, don't worry. All right. Anyway, we also have a report here of a leak summary. We have 400 bytes that have been lost, definitely lost, in fact. It's very, very emphatic that it's definitely lost. How? We allocated them here, and then we never freed them up. All right? So now let me show you what happens after we read this report, go back to our code, fix our mistakes, and run it again. How do I fix the mistake of the leak? Free the array. GCC. Right? And by the way, again, if I didn't use that G flag, I would not get that line number 8 there. I would just get this mysterious memory address that would be meaningless to me. Right? So I'm going to go ahead and run valgrind again. And hey, no errors in 0 contexts, no leaks, nothing whatsoever. That doesn't mean that it's bug-free. Right? This is bug-free. It's simple enough. Right? This is basically a hello world program for arrays. But it gives me a high assurance that there are no bugs there because it ran without any problems. Right? Okay, that's valgrind. Valgrind, and here I'll go ahead and make sure that you have that in your notes. You can do bounds checking. You can do it can detect memory leaks. Again, just remember to use the G flag. Otherwise, it'll give you a report. It'll just give you a report that at memory location XYZ this occurred instead of at line 5 it occurred, right? And it's going to be useless. Something that we'll look at later on is another dynamic and analyzer tool is called Perf Testing. Right? Perf Testing is simply just, I don't know why you need to shorten performance testing, but Perf Testing. And you use a tool called profilers. We'll look at gprof later on when we get into efficiency. And writing good, efficient code that processes in a matter of seconds or minutes instead of centuries or millennia, right? That's a little bit later. But one of the tools that we'll use there is gprof. G is just GNU's profiler. So you see a theme here, right? GNU, 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 all over the place. Does anybody know what GNU stands for? No? Okay. GNU is, nope, not, there we go. Is not Unix. Oh, come on, where is it? You're not going to tell me? All right, anyway, GNU stands for GNU is not Linux, or not Unix, excuse me. Right? It goes back to a fight between IBM and free and open source software people many, many years ago. But GNU is equal to GNU is not Unix, right? So what does the G stand for? GNU. GNU is not Unix. So what do we have here? It's a recursive acronym, right? There we go. I don't know how to write it. It's a search bar anyway. Who cares? Right? It's a fun little joke, right? There is no, it doesn't stand for anything. I'm sure that they said this is not Unix, and they needed a way of expressing it, and they liked GNUs or something, right? GNU, GNU, right? That's their mascot right there. It's a kind of a bull. What is a GNU? A wildebeest, right? There you go. So, no idea how they taste. All right. So, our last tool, of course, is what we're going to spend most of our time today, is debugging. Right? Do not do poor man's debugging. Right? Up till now, you've probably been doing poor man's debugging, right? And that's perfectly fine. But now I'm giving you a new tool. Now you can afford something better. Right? What is poor man's debugging? Printfs. Everywhere. Right? There is a bug at line 5. So I'll go ahead and put a printf at line 5 and see what value x has. Right? There's another okay, fix that bug. Go on to line 10, put a printf, because there's another bug there. Okay, fix that. Something else is screwed up. Line 5 is wrong again. Right? Put the printf back in there. Right? Go back and forth a million times putting printfs everywhere. That's a poor man's debugger, right? You are now going to be rich people because I'm going to give you a nice, very rich tool here. Use a proper debugger, right? GDB. Now, when I say proper debugger, if you want to, you can explore the debugger built into the CS50 IDE or to the VS Code IDE over here. I've not had a chance to do it. If you just hit this button, you have to do some configuration. So that's something for me to explore later on. And you have this graphical debugger. I'm going to show you a command line debugger, right? Which is GDB, right? It's a command line TUI, which is text-based user interface, right? Debugger. Right? A debugger is a program that simulates and runs another program and allows you to pause execution, view variable values, evaluate expressions, right? Step through the program line by line, or you can jump to a different part of the program. And GDB is what we're going to be using. And again, how do you use it? Usage, right? Compile with the G flag. If you don't compile with the G flag, it's not going to preserve line numbers, it's not going to preserve variable names, etc. Okay? So, let's come over here and get rid of that. Here I've got an array demo. All right, there we go. I've got a function that creates a random array of a certain size. It creates a random array of size n filled with integers in the range 0 through 9. I've got a function that computes an average of elements in an array. It simply sums them up and divides by n and returns the double. Right? The print array prints the given array to a standard output. And then I've got to define here n. Right? And what I'm going to do is I'm going to read that in from the command line. Tell me how many integers you want. And we're going to, this is seeding the random number generator. Then we're going to create the random array, print it out, compute the average, and then print that out. Okay? And all the implementations are down here. Pretty simple program. Let's go ahead and compile it. Array demo. Now, I hid something from you. I shut off all the warnings so that we don't get any hints as to what's wrong. Okay? So, a.out. Okay, I have to provide a number of elements. So let's go ahead and say 10. By the way, just predict here about what the average should be if I create 10 numbers between 0 and 9. On somewhere about like 4.5, 5, something like that, right? That's your expectation. Is that correct? Oh, I know. Is that answer up there correct?
Not a number.
It's a segmentation fault. So what the hell happened? So let's go ahead and open up our debugger here. GDB a.out. Okay? That opens up this debugging program. You see that it's waiting there for me to type commands. Now, it's not going to show me the code by default, so what I need to do is go layout src. Right? Now, when I start running this program, it will show me the code. Right? If I just start running the program, run, right? Then you see immediately here that the process exited with an error code of 1. It died somehow. Right? Why? Do you see what? There we go. What happened? Usage, a.out n. What do I have to give it? A command line argument. Am I at the command line right now? Nope. So how do I set command line arguments? Set args, and then how many do we want? 10? Right. Okay. There we go. Now run it. And now I get what I was getting before with a segmentation fault. Right? And where did it occur? Oops. Get that out of the way. Where did the segmentation fault occur?
Line 67.
Line 67. Did running it from the command line tell me that information? Nope. Running it through a debugger does. What's wrong there? I have no idea. Let's go ahead and run the entire program, walk through it line by line to see if we can figure out what's going on. So I'm going to set a breakpoint. You break, and I'll break at main because I want to start at the very beginning. And where does the program begin? At main. You can see that it's set a breakpoint at line 25. If you hit the arrow buttons, by the way, you can scroll through the source code. So at line 25, what does that look like? There's main. Right? You see this B plus over here? That's a breakpoint. When I run the program again, from the beginning, it'll stop execution at that line. Okay? Now, I can go ahead and step line by line through this program. Next. Right? So I'm setting n here to be n. Did that have any effect? I don't know. Let's find out. What value is stored in little n right now? Print n. 10. Looks like it worked to me. I wonder what value is stored in n. We'll print n. Big N. No symbol n in current context. Why is that? What is big N? It's a macro, right? Compiler doesn't know anything about that. Why? Because that's the preprocessor's job. The preprocessor has gone through and eliminated all of the references in the source code to big N and changed them to 10. You don't see it here because this is your original source code, but that's what happened. Okay? All right, let's go ahead and go. Now, let's print argc, and it has a value of 2. So it is equal to 2, so would we expect to go into this if statement? Nope. In fact, if I go next, we go after that statement. Now, next is so common that I can go ahead and just go n, right, and go to the next, right, shorthand. Okay? A to I, if you want to, you can jump into a standard library function, but that's only if you've compiled it with the G flag, and you didn't compile it, so there's no reason to do that. Right? So what I'm going to go ahead and do is go next, right? Print n, right? And it retains that value of 10 because we didn't provide a command line argument, right? And then we've got random array here. So if I just hit next, what's going to happen is it's going to go to line 36 here because it's going line by line by line. Something might have happened in that array, right? In fact, let's print out the array to see what we got. Print ARR. Uh-oh. Does that look like an array to you? Nope. What is it? X0XA. That's just a memory address. Why is that? What is ARR? Pointer. It's just a memory address. I want to print the contents of that array. To do that, I will go print ARR. And do we know how big it is? 10. So the syntax is @ 10 on the size. And it'll print out all the contents here. Does that look right? No. So I have a suspicion here that something happened inside this function. But I've already stepped over that function. Okay, fine. What I want to do is I want to set a breakpoint at line 35, break 35, so that I don't have to go through that process again. I don't have to go line by line by line by line. I want to get immediately to this line and see what happened. Right? Let's run it again from the top. Right? Sometimes you have to refresh or just select all so that it looks better. It looks fine on my screen. It looks terrible on the overhead. I don't know why. All right? Anyway. I am at line 25 right now. Right? I don't want to have to go line, 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 line. So if I've got 2 breakpoints, I'm going to continue from this breakpoint down here. Continue. Right? And it'll jump all the way down to that other breakpoint. Because if you've got 1,000 lines of code here, hopefully you don't have 1,000 lines of code that's screaming out to you, break that up into different functions. But if you've got a very long lines of code, you don't want to have to go next, 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 next. Right? All you'd have to do is set a breakpoint, continue all the way to that other breakpoint. Now, what I did before is I hit next to go to the next line. I don't want to do that. I want to go into that function to find out what's going on. So I will step into that function. And when I do that, see, it jumps down to line 44. Right? Okay? And now I'll go next, next, next through this entire process. So next, next, print A. Right? That looks like a valid memory address to me, doesn't it? I mean, it's a random memory address, but it looks legit. Right? At least it's not null. So malloc must have worked, right? We asked for how many integers? N integers. How big is an integer? Int. So it looks like it works to me. If we print out that array at 10, there we go. All right, it's a bunch of garbage, right? So I'll go next, next, print. Now that should have set the first one, a sub 0. And look, that's much better, right? Instead of that garbage before, what do we have now? 3, right? Okay. Next, next, print a sub 1. It randomly assigned a value of 9. Let's print out this array again. Print array at 10. Right? Oops. Print a at 10. Okay. I need something else. Print star a at 10. Does that work? If so, I'll explain it. There we go. All right. If you, it will print the memory addresses if you don't put that dereference in front of it. So to print the contents of that array, 3, 9, remember it set the first one to 3, it set the second one to 9, dot, dot, dot. The rest of them are by default 0 here, right? Then you need star because it is a pointer. You dereference it, and then you use the at symbol and the size of the array that you want to print. I think if you do something else like print star a at 5, it will only print the first 5. Right? If you do print star a at 15, what's going to happen? How big is it? It's only of size 10. So what's it going to print? Oops.
Garbage.
Garbage after that, right? It's not 0. It's going to be that some dead beef value there. All right? But it will print out whatever it is. All right. So next, 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 next. Print a at 10. And you can see that it's filled up now the first 5. Okay. Next, 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 next. It's a small loop, only 10, so I'm going to go ahead and go through it. Next. Next, next, next. Oh, I went too far. I did that on purpose, right? Why did I do that on purpose? Because I want to stop at the last iteration of that. And I don't want to have to do it over and over and over again. I don't want to have to do this 10 goddamn times again just because I missed the last one. So let's go back to that line. What was it, by the way? What line? Random array, say line 48, break line 48. What's the, I have to look it up. Break 48 if I equals 9. Why I equals 9? That's the last iteration. So if you've got a really huge loop that runs 1,000,000 times, you have to sit there and go next, 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 999,999 times just to get to the last iteration? No. You set a conditional breakpoint here. If I, the index variable there, is equal to 9, then break. Right? And unfortunately, I don't know if it's going to do this for me if I'm not in that context. Oh, nope, it is. Great. So let's start again. Run. Yes, from the top. Continue. It goes to that line. Continue. And it goes all the way down there. Print I. And you see that I've skipped those first 9 iterations. I'm already at the end here without having to go next, 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 next. Right? And then accidentally overjumping what was my target. All right, next, next. Let's print, before we return, let's print out this array, a at 10. That certainly looks like a random array between 0 and 9 to me. So what's the problem? I'm not computing the average yet. All I'm doing is doing the average, the random array. Next, next. We return from the function, refresh, but we've got array at 10 is invalid memory location.
You ever actually return the pointer?
Bingo. What's my return value? Right? Nothing. What should it be? That A that I created. So let's quit out. We found our first bug. Let's quit out of our debugger because we do need to compile. You can do what's called hot debugging and change stuff and then recompile it on the fly. I forget how to do that off the top of my head, so don't ask me. Right? I'd have to look it up. Change the source code, GCC it again, and let's run it again. 10. Ooh, cool. Average of 109, that seems suspect, right? The average of values 0 through 9, could it be 100? No, if all the values were 10, that's the maximum value, say, right? Divide that by 10, the maximum value should be, 1, is it? Or 5 or something, I don't know, whatever, right? 10 times 100 divided by, yeah, it should be a maximum value of 10. But we have 109 here. So we've got yet another bug, but it's not seg faulting anymore, right? So fire up GDB. Remember to set your arguments again, set args to 10. I'll keep it small. Layout next, or layout source, so that I can see it. Give yourself some more room. Right? Break at main and run. Right? Now remember that we fixed everything to my satisfaction up until this point. So computing the average of, and then it prints out the array. And why didn't you print out the array? Oh, I don't know. It should have. Maybe it's not flushed yet. But anyway, let's find out what's, if I go next, that average is definitely not correct. 109, it's the exact same average as before. So something must have happened between these two lines. What is that something? The average function. So let's go ahead and set a breakpoint at the average function, average. All you have to do is give it the name. Let's run it again from the top, refresh it, there we go, and continue. Now I'm at the average function here. Now let's walk step by step. Next. All right. Before we actually do anything here, let's print out the values. Let's print A at 10. Right. So those are the values. I pull out my calculator and I found out what the average should be. That looks like 10, 20, 30, 42, 49. 49 divided by 10 is 4.9. That's my expectation. Right? So let's go ahead and go next, 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 next. All right, it's summing things up. Print sum. 20. Does that look right? I don't know, because I started at line 55, right? So let's rerun it again. Right, refresh. And continue. Next. Now before we sum up the first one, let's print out the sum value. Print sum. Right? What's immediately apparent? Before we've even added the first element, right? Print A 10, right? We have a sum value of 10. Is that right? Why? What did sum start at? What value of sum does sum have between 55 and 56? Uninitialized. Right? So there's another bug that we found. Right? To find that out, of course, you can go ahead and also set a watch point, watch variable. Watch sum. Right? Actually, no, I'll do that in a second here. So quit, yes. Fix it again. What should I have done to sum?
Initialize.
Initialize it to 0. Oops. There, equals 0. GCC, and GDB this, and layout next, set args 10, layout source, run, layout source, next, or break at average, and run. And come back up here. And you can see why I go to the command line. So I had, this is why also, if you're a developer, how many screens should you have? More. Yeah, that's a good, excellent answer. You should always have more, right? At least 2, right? At least, look at me, I'm just doing OBS and I've got 3 up here, right? I'm not even doing development, I'm just doing a presentation, right? If you're a true developer, you have to have a minimum of 2 screens. If you are a super developer, so one of my office mates in Lincoln, she had some extra money, so she got one of the, I don't know who produces them, but it's a 4-foot screen, 4-foot wide screen curved. Any idea who makes those? Is it Samsung?
I think I saw it at NFM.
Okay. You can get it at NFM. How much is it? Do you know?
I do not know.
That's it? Okay.
That sounds, let me look it up.
I'm going to NFM after this. Actually, I'm not. I'm going to go at home and watch the K-State Nebraska baseball game. While I'm doing that, I'm going to look it up at NFM. If it's only $800, man, that's a steal. That's awesome. And anyway, that's not her only screen, by the way. She's also got a TV screen over here, and she's got another widescreen, her older monitor that she's turned on its end so that she has a very tall screen instead, right? So the more is the excellent answer.
Does she feel loud?
I have no idea. I only see the back of the screen. I'd like to know what's on there, right? There's probably Netflix and then email and then whatever. Yeah.
Samsung Odyssey G9 is $999 for the 49-inch one.
Ooh.
I've seen the price of the 55-inch one, but
Okay.
it's a lot.
55-inch? Jeez. All right. Excellent. Well, now I've got to check my bank account. All right, so where were we here? Let's see. There we go. Now we're at the average. I don't want to have to keep printing out the sum every single time. So let's go ahead and print out A at 10. Right? And what's my expectation? If I do this on a piece of paper over here, the sum should be 0, starting at 0, then 9, then when we add 8, it should be 17. Then when we add another 9, it should be, help me out, 26, right? Then when we add another 6, it should be 32, right, et cetera, et cetera. That's our expectation. I would write that down, and I would watch this as it goes through. But I don't want to have to print every single time, so I'll watch sum. And every time sum changes, it'll tell me the old value and the new value. So that when I step through this, right, the old value was 10 because it was uninitialized, and now it's 0. When I go through the first iteration, it's now 9. Goes from 0 to 9. Then what was our next expectation? 17, 26, then I think 32. All right, so I'm kind of convinced that this works. Right? Dot, 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 dot. Dot, dot, dot. All right, before we return, print out sum 1092. Is that right? That would not meet our expectations that we wrote down on a piece of paper over here, certainly. That's way too much. Strange.
Going out of bounds.
Yeah, we seem to be going out of bounds. From 52, we jumped up to 1092. Why? Same error as before. And we're short on time, so does anybody see the last error? Print sum, print n. So 1092 divided by 10, even if 1092 is correct, and I return, what should this be?
Sum's an integer, right?
Yep, so next, print AVE. 109. We lost precision. It should be 109.2, right? So we found 2 bugs at once. What were those bugs again? That and double, right? These are bad bugs, right? These are intentional bugs, right? And if we had just compiled with a wall flag and a extra flag, it would have told us that half of those bugs right there. What, no?
I spent like 2 or 3 hours debugging my code last night to figure out that I did that exact thing. It was really upsetting because I literally put like a print statement after every single
Poor man's
calculation.
debugger.
I pulled out a calculator and calculated everything just to find out it was the wrong type of error.
He changed the return type on his maximum function to integer.
Oh.
So it's getting 0 every time because those values are all.
It's always between 0 and 1 or something, yep. Yep. But now you don't have to do poor man's debugging anymore. You can use a real debugger.
Well, now we're
Right.
going to check that next time and I won't do that again because
Yeah, once you, there's actually a philosophical undertone here. There have been developers in the past, some influential people that say debuggers should never be used, or debugging is an impossible process, and it's a philosophical question. So, I guess not to get religious or anything, but could God create a rock so heavy that he couldn't lift it? Right? It's a kind of a paradox, right? Because if he could, then he's not all powerful, and if he can't, then again, he's not all powerful, right? So are you smart enough to fix your own mistakes? Right? That's the equivalent here, right? That there are people who say that you shouldn't, that debugging is a stupid process because if you're not smart enough to write good code to begin with, you're not smart enough to figure out the code that you screwed up, right? I don't buy that, right? That's bull, right? All you need to do is use the proper tools. Once you take a second look at it, right, then it kind of falls into place here, right? As long as you're able to see the nitty-gritty of what's actually going on, right? This goes into something called rubber duck debugging too, right? What if I was speaking to an empty classroom? It's half empty, right? Something's going on, or everybody's relying on the live stream. Hopefully they're relying on the live stream, because when they get to debugging, they're gonna, what the hell is GDB? How do we use it? Right? So what, would this have been just as effective if the room was empty and I was just talking to empty air? Yeah, it's called rubber duck debugging. So the best way that you can debug something is by explaining it to somebody else. And if you can set it clearly in your mind and start explaining it to somebody, then you come upon your own mistakes. Right? This is what teaching is all about too, right? If you can explain it to somebody else, then you've learned about it yourself, because you've learned enough to explain it to somebody. What if somebody's not there? What you do is you take a rubber duck and you put it on top of your computer. I used to have a sticker here that was a rubber duck, and now it's a Shiva. All right, but it allows you to look at this and start explaining and saying, this is my error, right? It's returning, it's always returning an integer. It's always returning 0, right? These are the things that I've tried, and this is where I checked first, and I know it's not that, and this is the second thing I tried, and I know it's not that. And once you start sorting it out, and you're forcing yourself to put it in order to explain it to somebody else, and if somebody else happens to be a rubber duck, then that process is what leads you to the debugging, right? And this is a tool that can help you with that process. We literally call it rubber duck debugging. You put a rubber duck there, right? Yeah?
Yeah, a lot of times when I have errors, I get my friend on a Discord call, and I just talk him through what's happening, and then he'll say the stupidest thing, like, no, it can't be that, and then it's that. So it doesn't help just explaining what is wrong.
Exactly. And 9 times out of 10 in office hours when I've got somebody in there, I just start asking questions. Even if I see it immediately, I just start asking questions so that they can go there. Like, all right, well, what have you tried so far? What line number is it on, right? And if we just stare at that line number for a couple of seconds with look at that line number. Hint, done. They know what line number it is already because they told me, but just me telling them, look at that line number. Oh, that's right, I didn't do a typecast. Oh, that's right, I forgot a semicolon, and something simple like that, right?
Scroll up to the very top of your page. Okay, it's just that on here, they've got a rubber duck in the top right.
Where did you get that? Where did they think they got that? Rubber duck debugging. It is a common term. It's not, I didn't make it up, right? But that's what it is. It's rubber duck debugging. All right. Questions? No? Otherwise, I will make sure that you have most of these commands. There is I'll put it in the usage over here in the notes, but also when you go to your hack, let's see, on debugging, it's not here, it's an actual hack, sorry. Hacks, hack, what is it, 8? Is it not 8? It's 7. No, 7 should be arrays. Is it not? Oh, is it? Oh, it is 7. Maybe it's 9. Yeah, it's 9. Sorry, it's 9. 9 and 8 are inverted because of the weird 14-week schedule you guys are on. But in any case. There should be a cheat sheet here, isn't there? Oh no, the cheat sheet is over here. Here we go. This is the cheat sheet I wanted to give you. Right. So you can do a whole, all of the basic commands are here. Layout source, layout what's ASM stand for? Assembly, right? You can split things. You can actually look at the machine code, I believe, as well. Setting the text user interface variables and a couple of other cheat sheets there. I thought I had a full cheat sheet at one point. Oh well. Maybe it's here? I can't click that, apparently. Anyway, the cheat sheet is somewhere. It's just one sheet. In fact, I've got the sheet of paper taped to my office wall if I ever need to remember how to do something. And it's just 3 columns that have all the common commands in them. Yeah?
So, I know this course targets mostly desktop C programming, but because GDB seems like it's a powerful tool, is it applicable to more embedded scenarios?
Oh, yeah.
You might see?
In fact, not on this I don't know what the embedded systems looks like here on this campus, but the one that's done by Chris Bone on the UNL campus, you have to use GDB to defuse a bomb. So there's several exercises that you go through that you basically have to decompile the machine code and then run it through a debugger to find, say, a password, right? Or to find the value that it's looking for. It says like, the bomb is going to go off in 10 minutes. You need to enter in the password to defuse the bomb. And to do that, you have to run through a debugger to find out what branch of logic will defuse the bomb and then work backwards, and it's all just machine code.
Or I think another question I have is, so GDB is running on our hardware for our hardware, right, that we compiled it for?
Sure.
But if we're working with like a microcontroller and we have some sort of emulator or simulator layer, will GDB also be able to work with those?
Yeah, I think you can use, that might be called remote debugging, because the machine, the code is actually running on a different machine, and you want to debug it remotely. And GDB does support that. Most debuggers support that somehow. It's just that you need to read a tutorial on how to bridge to that particular hardware to remote debug it.
Awesome.
Right? Yeah. The term that you would want to look up is remote debugging. Another question? No. Okay. I will not see you again until after spring break, right? Spring
Yes.
break's next week, right? Yeah. Okay. Yeah.
Go through, like starting up the GDB, I kind of missed.
Oh, sure. Where are we? There we go. All right. So remember, you got to use the G flag, right? Array demo.c, right? Once you've done that, then you can go ahead and fire it up GDB, and then the executable was a.out. So you say, what do you want to debug? A.out. And then you're in GDB mode right now. And then you can start executing GDB commands. Set args, 10. If you have multiple arguments, then you just do that. Layout source is the other common one, so that you can actually start seeing the source. Right. Good? All right, have an excellent break.